Assalamualaikum. The topic for this week is sewerage treatment. Public sewage treatment. Plants in Malaysia. In Malaysia, extensive use has been made of primary treatment systems such as communal septic tanks and in-house tanks and unreliable low-cost secondary systems such as oxidation pond. In addition, large urban areas utilize individual septic tanks. Individual septic tank only partially treat sewage, discharging and influence still rich in organic material. This has the potential to create public health and environmental problems, particularly in urban areas. There are mainly two types of sewerage systems or services in Malaysia. The premise sewerage systems are either connected to a public sewage treatment plant or have an individual septic tank. Indah Water Consortium is mainly responsible for operating and maintaining the public sewage treatment plants and network of underground sewerage pipelines. The wastewater generation at home is either connected to the sewage treatment plant or the septic tank. Setting criteria for sewage treatment. The following criteria shall be observed when settling treatment plants. Plants shall be located as far as practically possible at the lowest point of a sewerage catchment basin so that sewage can be made to gravitate into the plant. Plants shall be located near to a suitable water course that is able to receive and assimilate treated effluent from the plant without reducing beneficial uses of the water course downstream. Setting criteria for sewage treatment. A relatively flat, non-waterlogged area shall be selected to accommodate the plant. A hilly or undulating to rolling area could necessitate the formation of cut slopes, a factor that could increase land area requirements, maintenance and stability problems. A relatively mild slope across the site could be useful in promoting efficient hydraulics. The shape of the land area selected shall be such as to minimize the extent of unusable area. Plants shall not be located in an area that will result in long-term operational problems or rapid deterioration of the assets. Setting criteria for sewage treatment. Plants shall be located near to a public road that allows immediate access from it to the plant. A freeway is not a suitable route. Plants shall be located away from existing cemeteries and gazettes reserved for cemeteries. Plants shall be sited away from religious centers. Plants shall be located away from eating places. Plants shall be located such that sewers are easily connected or conveyed to the proposed site. If temporary treatment plants are to be provided, they shall be located as near as possible to public trunk sewers. Plants shall be located away from children's playground. Sewage treatment systems. Simple systems, especially septic tanks, have been used to service small communities, although ever-increasing environment standards means that even these areas must eventually install better treatment systems. For urban centers where the population is concentrated and the receiving environment is not capable to cope with the waste discharge, sophisticated treatment systems have evolved, which produce a high-quality effluent. Processed using oxidation ponds are also sometimes used where large areas of land are available. The treatment process are divided into treatment which utilize oxygen to break down organic matter is called aerobic, and treatment which doesn't utilize oxygen is called anaerobic. The breakdown of organic matter can occur while in suspension or suspended growth, or on the surface of some type of media, which is called attached groove. Introduction to individual septic tank. The individual septic tanks is one of the simplest forms of sewage treatment. Individual septic tank is underground structure which built according specification for sewage treatment. Size of individual septic tank depend on waste discharge produced by those buildings. Example, individual house, school, hotel, or office. An individual septic tank comprises two chambers connected in a series, which can be seen in the next slide. In the first chamber, solids from the incoming sewage settle forming a slush, while greases and oils float to the surface of forming a scum layer. Influent from between the scum and slush layers then pass into the second chamber where further sedimentation occurs. Finally, the effluent leaves the second chamber and is discharged into a drain or allowed to percolate into the soil. The cross-section details for the septic tank. At the bottom of chamber, solids from the incoming sewage settle forming a slush, while greases and oils float to the surface forming a scum layer. The slush in the tank undergoes anaerobic digestion and is converted into more stable organic compounds and gases such as carbon dioxide, methane, and hydrogen sulfide. Individual septic tanks are usually designed for a 24-hour retention time. Enough storage capacity is provided so that scum and slush can be deposited in the tank for up to 2 years, after which it must be desludged to keep the tank operating satisfactorily. Individual septic tanks are suitable for single dwellings or individual buildings, example individual house, school, hotel and office, with a population equivalent or PE up to 150 and installed where there is no central sewage systems and where influent discharge will not adversely affect the environment. It is a cheap solution to disposing of sewage. However, individual septic tank only partially treat sewage, and concentrated groups of tanks can overload the capacity of the receiving environment, creating health and other problems. There are currently over 1 million individual septic tanks in Malaysia, making it by far the most common type of sewage treatment system. As we can see, the solids from private sewerage pipelines are connected to inspection chamber. Then, solids from the incoming sewage settle forming a slush in the bottom of septic tank, while greases and oils float to the surface forming a scum layer. Influent from between scum and slush layers then pass into the second chamber where further sedimentation occurs. Finally, the influent leaves the second chamber and is discharged into a drain. There are 3 different conditions happen in the septic tank, which has not been dislodged regularly, which has been dislodged regularly, and after dislodge. Individual septic tank process. The waste separates into slush, liquid, and scum. Its naturally occurring bacteria break down the slush and the scum. The solids that can't be broken down, settled at the bottom, and must be pumped out regularly. The liquid flows out of the tank into a network of underground pipes that drain into the septic tank. Its naturally occurring good bacteria in the soil feed on and break down harmful chemicals and bacteria, completing the treatment process. As we can see, finally the effluent leaves the second chamber and is discharged into a drain or allowed to percolate into the soil. An example, the installation of individual septic tank for house. All discharge from manhole 1, manhole 2, manhole 3 and manhole 4 are connected to the septic tank. The good location of individual septic tank are 30 meters away from wells, 15 meters from streams, and 3 meters from buildings and property lines. Oxidation ponds. The wastewater treatment in oxidation ponds is reliant upon naturally occurring communities of algae and bacteria which make up the photosynthesis oxygenation cycle. Algae photosynthesis provides oxygen, which drives bacterial decomposition of organic waste. The products of the waste decomposition are in turn assimilated into algae cells. These algae then produce more oxygen through photosynthesis to continue the cycle. The cycle process for oxidation ponds. Actual photo for oxidation ponds. Unaerated lagoons. Unaerated lagoons are relatively simple plants to operate and maintain. However, they require large land areas and are therefore rarely found in densely populated urban areas. The aerated lagoons process normally comprise 2 or 3 lagoons in a sequence. The first lagoon has surface aerators, which are like large paddle mixers. The aerators float on the surface of the pond and continuously stir the incoming sewage, serving to maintain oxygen content in the sewage and preventing any solids from settling. Aerated lagoons. Sewage has an average retention in the first pond of 5 days. During this time, bacteria consume the oxygen to breaking down the organic material in the sewage. Effluent is passed into the second pond where the degraded organic matter and sediments are settled out to form slush. The effluent may then pass to a third pond for polishing or be discharged to a receiving waterway. The average retention time in the second pond is 1 day. Unaerated lagoons. Care must be taken in managing the settling pond in warm climates. These ponds can suffer from algae growth and generated by anaerobic digestion of the slush at the bottom of the pond. Depending upon their design, these ponds must be dislodged approximately every 10 years. The whole processes for aerated lagoons. The actual photo for aerated lagoons. It consumes a large area. Introduction to manhole and inspection chamber. The manhole are inspection chambers over 1 meter to invert. They are compartments used to house an access point for making connections or performing maintenance, such as cleaning and testing, on underground and buried public utility and other services including sewers, telephone, electricity, storm drains and gas. Its material from brickwork or concrete units. The cover of manhole or inspection chamber are cast iron, pressed steel or concrete. There are two types of manhole: intercepting inspection manhole and backdrop inspection manhole. The cross-section details for manhole or inspection chamber. The cross-section details for the standard precast manhole. Another cross-section details for manhole. There are two shapes of manhole, either circular and rectangular, and the range size for the manhole is between 450 to 600 mm, and another one is 600 to 900 mm. The location of manhole. There are 5 ways to connect new drainage to an existing system: new branch pipe, hilly on a slope, long drain pipes, change in size of pipes, and change in direction of pipes. Thank you.